Alright, to finish up some notes on multiplicity and just general long division, so 2, 3, and 2, 4. Multiplicity is just about the idea that you want to get zeros to a function. So if you're looking at number 7 here, we got zeros at x equals 0 and x equals 3, things that would make that function equal to 0. X equals 0 has a multiplicity of 1 because its degree is 1, and then x equals 3 has a multiplicity of 2 because its degree is 2. Now there's meaning to that. Remember, an odd multiplicity of any kind, 1, 3, 5, 7, etc., means it's going to pass through. The root will go through the x-axis. If it has an even multiplicity, like x equals 3, you're going to have something that bounces, only touches at the axis. You also want to look at end behavior. You want to know that this function, if you FOIL it out, is something x cubed, so you have a sense of some kind of end behavior. So you know where the ends will go, one down and one up, left and right respectively. But you also want to know that the root at 0 passes through, and then you have a bounce at the root of 3. Next, same thing on the part B. You have odd powered root at 0, multiplicity of 3, and then x equals 2 is the other root. It's even. It means you're going to have a pass through at 0 and a bounce at 2. And this is, if you look at the total power of this function, you're looking at x squared times x cubed and negative, so it's negative x fifth end behavior, but also roots that pass through at 0 and bounce at 2. So there's a little sketch that would come from that. The next piece, long division, just a quick recap. If you haven't had much success with long division, you want to make sure you start with that x and the x minus 1 and see how many times it goes into x squared. And then that goes in x times, basically what do you multiply it by to go into x squared? Then you multiply through the binomial x minus 1 with that x and get the following. Change the signs and add down. That's effectively subtracting. Then when I bring down the next term to match up, I give you another binomial to match with the other. And you figure out how many times does x go into 4x? 4 times. Multiply through by that 4 and get this result. Change the signs and add down. What we find out when we have a remainder of 0 is that we have the 2, the quotient, and the divisor have, if you multiply them together, you get the original. Now, on to the next one, a little more complicated. You're dealing with 2x plus 1 going into the following function. 2x into 2x cubed it goes in x squared times. You multiply x squared through times x squared times 2x plus 1. And we get change of signs and add them down. That's like subtracting. Bring down the next term. Now 2x goes into negative 4x squared, negative 2x times, and then you multiply through, change the signs and add down. Bring down the next term. 2x goes into 4x just 2 times, multiply through, change the sign, and we get a remainder of negative 3, and you always write that over the divisor, 2x plus 1 in this case. Cool. Next is the remainder theorem. Basically is just talking about, if you have a remainder, what is your remainder? If you don't have a remainder, what does that mean? Well, I think we get the idea. Let's do synthetic in each of these cases. Pretty short and sweet. If I do synthetic division with 2, x minus 2, remember if x minus 2 is a factor, then 2 is a root, and that's what we want to use in long division, the root. Or I'm sorry, synthetic division, the root. And if you run it through, I get a remainder of 6. Well, that means 6 over x minus 2 is your actual remainder. If I go through with negative 1, I get negative 24 in that synthetic, but that means negative 24 over x plus 1 is the actual remainder. And if I do x plus 4 with negative 4 as the root, I get 0 remainder, which means x plus 4 is an actual factor of that x, the original polynomial in f of x. That's the story, and let me know if you have other questions.